Good morning, everybody. So I'm going to show you today how to use this guy right here. This is called a mole map. And the problems that are in this week's folder have to deal with doing basically mole problems. One step, two step, three-step stoichiometry problems, limiting reactants. And this guy's going to become very handy for you to use. This is a PDF actually in this week's folder. So if you want to print it off, that would probably be very good for you to do. And then you might want to write at the top of it liter, and then atom, ion, and molecule, because those are what the represented particles are. And then at the bottom here, go ahead and write down grams. So that way you don't really have to think, oh, okay, they're talking about volume. Well, what's that? That would end up being liters, all right? So it'll just make it makes your life a lot easier when you're working with these type of problems. So let's go ahead and get started, and I'll show you how to use this guy. So let's start with a really simple problem here, and that's just a one step. Let's say that you're starting off with 5.4 liters of oxygen, and you want to turn that into, let's say, moles of oxygen. How would you do that? Well, we talked about how you would use dimensional analysis. You'd use that little grid thing, and what you're given goes up here. So we'll put our number up here, 5.4 liters of oxygen. And then we're going to go ahead and grab this little mole map guy and figure, okay, well, what do we need to do to solve this? We're starting at liters and we're going to moles. So just follow the roadmap. We're up here at liters and we want to go down here to moles, and it shows you the conversion factor that you will use. In other words, what will go in this double-sided space right here. So if you follow the arrows, it says you're going to have 1 mole over 22.4 liters. So we just write that down, 1 mole over 22.4 liters. Don't forget to put what it really is. It's oxygen. You should have 2 labels here for every space, what the measurement is and what the substance is, and we have that. And then if you look, all you have to do is cancel those out, and you can multiply and divide and get your answer. So let's go ahead and do that with our calculator here. So if we take 5.4 and we divide it by 22.4, what's that give us? It gives us 0.25. Moles of oxygen, and that's our answer. So we're just going to round everything to the hundredths place. Let's try another one of those, because you don't always start off with something like liters. Sometimes you're starting off with moles. So maybe in this next problem, let's say we start off with 2.8 moles of iron oxide, Fe2O3, and let's say you're going to figure out how many grams of Fe2O3 that's going to be. That's what you're trying to find. So we'll go ahead and set up our grid again. Put our given up here, 2.8 moles of Fe2O3. We know that moles of Fe2O3 are going to come down here, so they can cross out just like liters of oxygen did. Well, let's go ahead and use our mole map. So we're going from moles to grams. So if we look, here's moles, and then here's grams. If you go straight down, you have the atomic mass over 1 mole. So you're going to do exactly the same thing. You're going to put your 1 mole down here, and your atomic mass for Fe2O3 is going to end up being after that. So grams of Fe2O3 and moles of Fe2O3. These guys are going to cross out. And what does that mean when we're going from moles to grams, and it's grams up here? Well, it's the atomic mass for Fe2O3. So you have to figure it out. You have to add it all up. So let's just do that in the calculator again and add up all those numbers. Let's say that let's take a look at our periodic table. We need to figure out what iron is, and iron is 55.845. So 55.845, we're going to multiply that by 2 because we got 2 of them. And then we're going to add that to 3 oxygen. So you could just say 3 times 15.9994. I'm just going to add it. Well, actually, now we'll do that. So 111.69. That's that number. And then we're going to take oxygen, which is 15.9994, multiply that by 3, and it gives us 47.9982. We're going to add that to the 111 that we got before for the iron, and that gives us a total mass of 159.688. 159.688. Now, because I'm only going to hundredths place here for my answer, That means that the stuff I put up here, like if I have to figure out an atomic mass, I probably want to go one more digit out, so that way I minimize my error. So I'm going to go out to the thousands place since I want my answer to be in the hundreds place. If I were to go out to the hundreds place, I would have a little bit more error. I want to minimize as much of that as possible. All right, so now let's go ahead and do the math. We're going to take 2.8. This is in the numerator, so we're going to multiply it by the 159.688. And then we're going to divide that by 1, which is the same number, and that gives us 447.13 grams of Fe2O3. All right, so there's another example of a one-step problem and how you would use this mole map to help you solve that. So let's now go ahead and do some two-step problems. And let's say for our two-step problems, we're going to go ahead and you're going to start off with 2.5 grams of NaCl, and we want to turn that number into, let's say, molecules of NaCl. What the heck would you do? Okay, well, because it's a two-step, I'm going to go ahead and set it up like a two-step problem. If you didn't know this, you'd figure it out from the mole map. It's not a big deal. So let's take a look. If you're down here at grams and you want to go up to molecules, you're going to do this step first. So it's a one-step. You only do mole over mole if you have a balanced equation. We don't have that here, okay? And then we go up here. There's our next step. There's our next conversion factor. So this is a two-step problem, all right? So that's why it's going to look set up like this. So let's put what's given here, 2.5 grams of NaCl. No grams of NaCl is going to come down here, but let's just use the mole map. So we're going down here and up to here and up to here. It says 1 mole over atomic mass. So we're going to put 1 mole of Fe2O3 over the atomic mass of Fe2O3. Oh, it's NaCl, wrong substance. Should pay attention to that. That happens, especially when you get in a hurry. All right, so NaCl, NaCl. So we got to figure out what the atomic mass is for that. So let's go ahead and add that up together. All right, so we're going to take chlorine off the periodic table is 35.453. And we're going to add that to sodium, which is 22.9898. And that gives us an atomic mass of 58.443. 58.443. Those will cross out. What are we going to do next? Well, we're here at mole, and we said we want to go up to molecule, so we have to have Avogadro's number over 1 mole. So we go ahead and fill that in. 6.02 times 10 to the 23rd over 1 mole. Now we're all set up and ready to go, and we can go ahead and do that calculation. All right, so we're going to go ahead and put 2.5 in here. We're going to multiply by Avogadro's number, 6.02 EE23. And then we don't have to multiply by 1, and we don't have to divide by 1, but we do have to divide by 58.443. And that gives us 2.58 times 10 to the 22nd power, and that's going to be molecules of NaCl. All right, so there you go. That's how you would do a two-step problem without an equation. So this is without a balanced equation. What would it look like if you had a balanced equation? Well, let's try one of those. Let's say they gave you Na plus H2O yields NaOH plus H2, and then you basically balance it. Well, if you look, you got 2 H's here and 1 H here, and you got 2 H's here. So this is 3, and that's 2. Well, I could make this a 2. 2 times 1 gives me 2 H's, and with those 2 H's, I have 4. I can fix that. I'll put a 2 there. And then I have to fix the NAs because there's 2 NAs here, so I need to put a 2 there. And let's say that they start you off with 3 moles of Na. 3 moles of this Na. And then what they want you to do is they want you to turn that into grams of H2 over here. So let's go ahead and give that a shot. So we go ahead and so again, keep these separate. So we go ahead and set up our grid, start with our 3 moles of Na, and let's take a look where we are on our mole map. So we want to go from moles to grams, but we have to be careful, we have an equation. So going from moles to grams, this is our first step. It's mole over mole. So mole over mole. And then we're going to have atomic mass over 1 mole. So grams over 1 mole. Well, let's figure out like what's all this about, mole over mole. Well, remember, this has to cancel with this, so the Na is down here. But what's the other substance the problem talks about? It doesn't just talk about Na, but they want you to turn it into H2. That's what the mole over mole step allows you to do. It allows you to use the balanced equation to go from moles of A to moles of B, or moles of one thing to moles of another. All right, and how do you do that? You use the coefficients you balance with. So this H2 has a 1 in the front of it. So we put a 1 there. This Na has a 2 in front of it in the equation. We put a 2 there. So these numbers come when it's mole over mole. Only when it's mole over mole, not when it's gram over mole. But when it's mole over mole, they come from the balanced equation. And this 2 came from this coefficient over here in front of the Na. So that's where those numbers actually came from. All right, we're almost there. Remember, if you're like, well, what's labeled here? I don't know. Well, this has to cross off with this. So bring your H2 down, and then this is going to be H2. So the only time you switch from one thing to another, when it's in the bottom or the top of the conversion factor, is when it's mole over mole. Notice that anywhere else, it's still the same thing, NaCl over NaCl, NaCl over NaCl, O2 over O2. Only when it's mole over mole does it allow you to switch to a new thing. So let's add up what H2 would be. Well, H is basically 1. It's 1.007974. So if we double that, that's going to give us 2.015. And we can go ahead and go through and we can do our math. So we're going to take 3 times 2.015. And then we're going to divide by 2. And we don't have to multiply or divide by the ones because it's going to be the same number, and we get 3.02 grams of H2 as our answer. All right. So that's with a balanced equation. That's how you do with a balanced equation. What about a 3-step, which is a stoichiometry problem? So what would you do in that kind of problem? Well, they give you an equation. So let's say they have AgNO3. And you're going to react that, let's say, with zinc metal. And there will be a reaction. This is a single replacement reaction. Compound and element makes another compound and element. This one's going to be ZnNO3, 2. And then we have H2 left over. And to balance it, no, not H2. We have Ag. And then to balance it, we got 6 O's. We only have 3 here. So we got to put a 2 there. In the process, that messes up the Ags. So we got to put a 2 there, and that makes it balance. So let's say that you start off with 5.5 grams of this stuff here, AgNO3. And then they want you to figure out how many grams of this that you're going to have, of the Ag. Well, you could use your mole map to see that it's going to end up being a 3-step problem. Or if you know it, just go ahead and put it down, if the problem tells you. So let's see where we're at. We're going from grams to grams. So you're doing like a U shape here. You're here. You're going to do this first. You have an equation, so you do that second, and then you come back down. You're going to do this third. All right. You could go up here, like maybe they want you to figure out molecules. So it'd be like, this is your first step. That's your second. That's your third. But they don't want you doing that. They want you to go back to grams of a new thing. So you're doing this first, that second, that third. So 1 mole over atomic mass, grams of AgNO3, 1 mole over the atomic mass of AgNO3. Right? And then we're going to go ahead and have to add up all this stuff. So to do that, oxygen's 15.9994. We're going to multiply that by 3. We're going to add a nitrogen to it, which is 14. Let's see, what is it here? It's 14.00674. And then we're going to add a silver to it, an Ag, which is 107.868. And that gives us 169.873 is the number that we're going to end up using down there. Okay, these should cross off. Go back to your mole map, see where you're at. You did this, you're now here, mole over mole, mole over mole. And you're going to go ahead and probably figure, well, what mole over what over mole over what? Remember, this is like mole of A over mole of B, so it's going to change. Whatever this is, AgNO3 is going to have to go down here because they're going to have to cross off. Look at the problem. They give you AgNO3 and they give you Ag. So Ag has to be the top thing. All right. Ag has to be the top thing. So now let's go ahead and put those numbers in here. Remember where we get them? Where did we get them? Up here from the equation. So in front of Ag is 2. In front of AgNO3 is also a 2. And then you're now on your last step. You're almost there. So we're going to have to now go, we just did this, we did this, now we're going to go back down to grams. It's atomic mass over 1 mole. So atomic mass over 1 mole. Well, 1 mole what? Again, this has to cross off with this, so you know it must be for Ag. So when we look that up on the periodic table, what's the atomic mass for Ag? It's 107.868. 107.868. And now we can go ahead and go through all this and figure out what our answer is. So we're going to take 5.5 and we're going to multiply it by 2. And we're going to multiply it by 107.868. And then we're going to divide by this, 169.873. And then we're going to divide by 2. And that gives you 3.49 as our answer. Grams of Ag. A lot of work, but if you use this little guy right here, the mole map, it makes your life a heck of a lot easier. All right. The only thing I haven't shown you is how would you do a limiting reactant problem. All right. And basically, anytime you do a stoichiometry, you can start with grams, you can go to liters, or you could start from liters and you could go to molecules. Well, limiting reactant problems are the same exact way. The only difference is that they will give you a second number. Like maybe they give you 4.3 grams of this guy, zinc. So when they give you 2 numbers, that's a limiting reactant problem. And you do it really the same way. We just did the first part where we turned this guy into grams of silver. You would do another one right underneath it where you would start from grams of zinc and go to grams of silver. And then your lowest one would be the winner. Okay, that's how you would figure out and how you would do a limiting reactant problem. So it's just one more step added onto this. It's not really more complicated. You'll know you'll have a limiting reactant because they'll give you 2 of these. And you just do the same thing. You just do 2 problems. Turn this one into what they want you to find, and then turn this one into what you want to find. And the lowest number is going to be your limiting reactant. All right. So that is basically how you use this guy right here, how you use the mole map. And I hope it makes your life easier as you work through the problems this week. All right. Take care, everybody. Bye.